right, let's first take a look at three-dimensional figures, some properties of these, and then from here we'll build into surface area and volume for prisms and cylinders. So first of all, we have solids. We've been looking at polygons, which are two-dimensional. Solids are three-dimensional figures that enclose a part of space. So I have one drawn over here to the side. In class, we kind of do a few little exercises at looking how to see things three-dimensionally. Even though obviously this is flat, it's 2D because you're looking at it on your screen, we want to see it 3D. So using the program, I drew in two boxes and connected the corners. If you want to draw one yourself, you just can draw a rectangle, and then you can draw another overlapping rectangle, and then just connect the edges. Using this program here, I did that, but with some of the lines, they end up getting behind the square or the rectangle, and so that's why it's drawn in. But we're going to use this diagram to help identify these these terms. So solid is a three-dimensional object enclosing a part of space. So like a cube, a cone, a prism, a cylinder, things like that. And we'll talk about those down below. Now there are things on each of these solids known as faces. Now faces are polygons. They're polygon-shaped sides. So in this case, we have this face here. This is a face, this is a face, the back is a face, the bottom, top. Now we have things called edges, and that's where these faces meet. So our edges are where the faces meet. So this, oops, wonder why it came black. Let's make it blue. This here is an edge. This is an edge. This is an edge. This is an edge. Okay, so those are my edges. All right, and then we'll label this faces. This whole panel here is a face. The edges are where the faces meet. And then we also have things known as vertices. So vertices are like these corners, if you want to write that in. I'm not really defining these too much written out in words, but rather using the picture here. Again, you can always check out the book for the actual straight out definitions, which will accompany this picture. So our vertices are the places where the edges meet. So basically any of the corners where the edges meet. This is meeting here. This corner is where all of these edges are meet. That's a vertex. Vertex is the singular, vertices is plural. So we have a couple different vertices on here. 1, 2, 3, 4, 5, 6, 7, 8. Now surface area is the dimensions, is the area of each of our sides necessarily. So it would be the area of this rectangle, then the area of this rectangle, the area of the top rectangle, the side, the back, the bottom. All of our rectangles, because this is actually a prism, if we would find the area of each of those and add them up, that's our surface area. So one way of finding surface area is to go through, and let's say you have a figure, you could almost like stamp it. Like we would stamp it, that would be one rectangle, another, and we would take each of the sides, maybe one of them would be a little longer, that would be our top and our bottom, and we would find the area of this, and this, and this, and this, and this, and then go ahead and add them all together. Okay, so that's one method. We, though, aren't going to do it that way. That's a little bit time consuming, and most often we're looking at problems where we're kind of conceptualizing or visualizing the prism. We don't actually have it in our hand to go ahead and trace it out on paper. But surface area is when you add up all the area of each of the sides, okay, each of the polygons that form the sides. Now the net kind of goes along with this possible method that I just sketched out over here. If I were to take a rectangular prism like the one I had up above, and if I were to somehow unfold it, like unwrap all of the sides, I would get, for this example, something that would end up looking somewhat like a cross. These would be my two sides, and then I would end up having my four faces that would unfold as well. So rather than just stamping it, as I mentioned, we could take the area of each of these pieces and then add them all together, and that would tell us our total surface area using the net. So this is an example of a net. Again, we aren't usually going to be working with actually having something in our hands. We may use that to help us visualize it, but we're going to be looking at situations where we're conceptualizing it or looking at pictures. So the net is a good thing to be able to see from a figure, but we're also going to analyze some formulas that help us go from there. Okay? All right, now let's take a look at 4 specific types of solids. prisms, pyramids, cylinders, and cones. We are going to, in this lesson and the next two lessons, we're going to focus on prisms and cylinders specifically, but we want to understand what pyramids and cones are. So prism, you can have a rectangular prism, such as this, okay? And again, I apologize for the sketchiness of it. This is a rectangular prism. You could also have a triangular prism, and we'll take a look at those. This is a triangular prism. And you could basically go on from here any different kind of prism. Maybe you'll have a hexagonal prism, and we look at one of those in class. So that would look something like this. Okay, so there's a whole bunch of different prisms you can have. We're going to focus on rectangular and triangular prisms. And now there's a few components we need to understand. First of all of the faces are rectangles. Our two bases are congruent. So in this case, with the rectangular prism, it's hard to identify, but when we look at the triangular prism, all of the faces, this is a rectangle, that side over there is a rectangle, the bottom, what it's sitting on, is a rectangle, and then we have this triangle here and here. Those would be our bases. These two bases are congruent, and they're congruent with one another, and they're parallel. They're in parallel planes. So in this hexagonal prism, that's a base and that's a base. So we want to understand that base doesn't necessarily mean the object is sitting like flat with the base being the bottom. The base is whatever your like special side is in that case. So here we could choose, now with the rectangular prism, the reason I said it's not as easy to identify is because all sides are rectangles. So there it doesn't really matter what you identify as your base. But if you have special sides like triangular or hexagonal prisms, you have to choose those special sides as your base. Okay? And then again, it's a solid where all the sides are polygons. So made up of all polygons. All right, now let's move down to cylinders because that's another one we're going to focus on. Cylinders, ooh, that's a little sketchy. Cylinders, notice, do not have any polygons. This is a circle down here, and this is all smooth. So we don't have any faces necessarily. When we unwrap it though, we end up getting something that would look like a circle up the top. This smooth part around the edge ends up being a big rectangle, and then we have a circle down at the bottom. And that's the net that we'll look at later. So we have two congruent bases that are also parallel, in parallel planes. And then this side here is not necessarily made up of any kind of polygon, so that's all we'd really want to list. A pyramid, we're familiar, let's draw this in red as well, or pink. Now again, pyramids, you can have a whole bunch of different style pyramids. You can have, this is more of a rectangular pyramid. You could have a triangular pyramid, a hexagonal pyramid, and the way you define it is whatever your base is. So you only have one base with these examples, one base. And your faces are all rectangles, or triangles, I'm sorry. Your faces are triangles. So this triangle here is a face, triangle, triangle, triangle. All right, now the last one's a cone. A cone has a circular base, and that's it. So a cone's base is circular, and there's only one. One base, okay? So that's all. Again, I didn't go too much in detail, but you do want to recognize the different solids, and from there we're going to analyze these two in particular. So let's go on to the next side.